In the previous video, we launched a blender straight upward at a speed initially of 37 meters per second. In this video, we're going to launch a toaster, but we're going to launch it at an angle. The initial launch speed is 56.4 meters per second, and the initial angle above horizontal is 41 degrees, and we want to figure out how long this is in the air, how high it goes, and then also on the next page, its range. Well, the first thing we want to do whenever we have a projectile that is launched at an angle is we want to find its x and y components. That is, we want to find Vx and we want to find Vy initial. We say Vx without any I or F by it because the x velocity is constant. But we have to say Vy initial because this velocity, whatever it is only good for an instant. It changes immediately after that due to the acceleration of gravity. Let's first calculate Vx. Vx from our right triangle is going to be the hypotenuse times the cosine of 41. We have done this many times when we were resolving vectors. 56.4 meters per second times the cosine of 41. And to three significant figures, that comes out to be 42.6 meters per second. Vy initial is going to be 56.4 times the sine of 41. To three significant figures, that comes out to be 37 meters per second. That is exactly the upward launching speed that we used in the previous video with the blender. Therefore, the time that this toaster is in the air is going to be the same as the blender. The same as for the blender. See video 2D39, 7.54 seconds. The fact that this toaster is also moving horizontally makes absolutely no difference. The only thing that determines how long it's going to be in the air is the vertical motion, not the horizontal. What about the maximum height that the object attains? Isn't it also true that the maximum height is determined solely by the y velocity? The x has nothing to do with it, which means that this toaster is also going to reach the same exact height that the blender did. So you might need to look in the previous video to figure out what that is. We showed you how that's done. It's going to go exactly the same height. What about the projectile's range? Now, the range of the projectile is dx. And how do you find dx? According to our little cheat sheet here, find dx, you need vx, and you got to multiply by time. We know what vx is because we just found it on the previous paper right there, 42.6 meters per second. What this means is every second that this toaster is in the air, it moves to the right 42.6 meters. The next second, it's moved another 42.6 meters to the right. And it does that every second for 7.54 seconds. 42.6 meters per second to the right for every second of these 7.54 seconds. That comes out to be 321 meters. That's how far away that toaster is going to land. If you launched the toaster, it would have a trajectory that would go kind of like that. And that would be 321 meters right there. And the height, obviously this isn't to scale, the height is 69.8 meters. That's the toaster. The blender which was the previous video, the blender did this. Watch my pen. But the time was the same. The maximum height was the same. And the reason the toaster and the blender reached the same vertical height and were in the air for the same amount of time is because they shared the exact same vertical velocity initially. The only difference with the toaster is that it's also, you can see where I'm pointing here, it's also moving sideways, which is why it lands way over here. An angled projectile stays in the air as long as and goes as high as a straight up projectile launched upward at the Py initial of the angled projectile. Boom. The only thing for an angled projectile that determines how high it goes is the y component of the velocity initially. For an angled projectile, the only thing that determines how long it's going to be in the air is the vertical component of velocity initially.